Number 37, 2-mark question. So here the question is a little bit confusing. So here might be the data is insufficient. So I am drawing the circuit. So here we have a bridge circuit for which input is 4 volts, and we are having other 3 arms as all the 3 arms of 800 ohms, and here we have our galvanometer connected. So here if I take R1 as my transducer, which is initially of 800 ohms, so we need to calculate what is the new value, nothing but delta R plus R. This we need to compute. So here the galvanometer current is given as 0.8 microamperes and internal resistance RG is 100 ohms. So P and Q, if I take these two nodes as P and Q, so here we need to calculate what is the new value of resistance for this current, if I assume in that way the question. So we need to calculate what is R1, which is nothing but 800 ohm plus delta R. This value we need to basically we need to calculate delta R and add it to 800 ohms. Is what. So here we can do it in many ways. The first the approach which I take is, so here when balanced or when in the initial phase, so what is the equivalent or in the initial phase Thevenin's equivalent across P and Q is RTH is nothing but 800 parallel 800 plus 800 parallel 800, which is nothing but 800 ohms. So what could be the voltage reading here is VG, galvanometer reading is nothing but IG times R Thevenin plus galvanometer resistance. So here IG is nothing but given as 0.8 microamperes times RTH we have calculated as 800 and galvanometer resistance as 100 ohms. So this comes to as 0.72 millivolts. So this is the new voltage that is developed across my galvanometer, millivolts. So here, because there is a change in resistance, now the bridge is no more balanced, so we are getting a voltage of 0.72 volts across the galvanometer. So this voltage has to be, because this is the voltage. So if I write write KVL inside this first loop, so this voltage should appear across this one only. So when the bridge was balanced, what was VR1 when balanced? Was 2 volts, because equal resistance, so voltage is 4 volts, so it get divided into half. So here 2 volts and here also 2 volts. The bridge is balanced. Now because of delta R resistance, due to delta R resistance, VR1 new is nothing but 2 volts plus 0.72 millivolts, which comes as 2.00072 volts. So now this is a new voltage. So now what is the voltage across VQ is nothing but 4 minus 2.0072, so which is nothing but 1.99928 volts. So now we can calculate IQ, which is nothing but VQ divided by 800. So what we get is 2.4991 milliamperes. So because they both are connected in series, the same current flows through R1 also. So now we know we know IR and we know VR1. So R plus delta R, the new resistance is nothing but VR1 by IQ, which is nothing but IR1. So what we get is, so if I substitute 2.00072 divided by 2.4991 milliamperes, what we get is 800.576 ohms. So please correct option C. Correct. So I am writing it down. Correct option C, which is nothing but 800.576 ohms. So key is B. Sorry, correct option B. So correct the option. So please correct the option B. It is nothing but 800.576 ohms. So the correct key is B. Thank you.